All right. So welcome to having your pick of the litter, storing malware stagers and enterprise services. This is a very Windows heavy talk. I'm a Windows guy. A little bit about myself. I'm with the Department of Defense. Been with them roughly 18 years. Started off as a system administrator. Moved into SOC defense, if you will, about 6 years ago. Led an incident response team through a number of high visibility incidents, and then moved over to vulnerability assessment, red team, if you will. And now I'm a technical director of an operations center where we do both vulnerability assessment, red team, and incident response. I'm a adjunct cybersecurity professor at a local college down in Augusta, Georgia. That's where I come to you all from. Developed a number of red and blue team tools. I like PowerShell. You'll see that throughout this, and I'm out there on the interwebs in a couple of places. All right, so here's the agenda. We'll really highlight the history of such, talking about some malware, talking about a kill chain or a methodology. We'll go through utilizing said methodology or tactic to hide stagers and enterprise services. And then I'll end this with a demo in which I'll highlight or really walk through each one of those things. All right, so first we got to kind of start off with definition. So this whole malware thing, right? What is this? Well, you see a lot of text up there, but really the meat and potatoes of it is that malware is going to be an actual piece of code developed by somebody to actually inflict something on a person's machine, whether they want to actually take it down, whether they want to take over it, but nonetheless, it's going to be code at heart. It's kind of interesting when we think about malware. Now, there's different variations of it, but before we even get into that, let's talk about where it all started from. Well, roughly back in 1971, there was a guy by the name of Ben Thomas who actually developed the creeper malware. And literally what it did is print to the screen, I'm a creeper, catch me if you can. And it propagated by hand. It was very manual in nature. We're talking floppy disks, right? Can't even find a floppy disk these days. I say that lightly because some organizations still have them. But that was the first piece of what we know to be malware. And it relied on human interaction. That's kind of interesting because now today we don't see human interaction being a necessity as much, right? And today we see things that are much more sophisticated, right? Much more streamlined, maybe broken up to different phases, if you will, and they're constantly evolving. It's a constant cat and mouse game. From a defense perspective, you're consistently trying to highlight what adversaries are doing, trying to put things in place in which you can articulate and really highlight the activities that they're doing. And as a red team or vulnerability assessment person, you're just sitting there trying to find some loophole, fuzz that software and find something that allows you to gain some code execution, and even better, a root shell is really what we're after, right? But it also has some financial gain with it because we have criminals doing it for the purpose of financial gain. We have governments doing it, right? Trying to get after the political gain. And in all honesty, it's almost like a silent war happening that we don't see on the streets or really see as much in the news unless it's some wide known company of sorts. So when we look at the common types of malware, right, we see what's before us. And generally speaking, I think worms and viruses are kind of the thing we previously always thought about when we mentioned malware. But now we see a lot of ransomware, definitely financial gain, right? Where somebody's trying to get code execution on the system. They want to encrypt the drive. They want to hold the system for ransom. We see rootkits. That's always been a thing, right? There's user mode. Most common, there's actual kernel level, very sophisticated, right? At that point, it makes it a little bit more difficult to trust the system, to really even identify it. And then you have like a hypervisor version of it so we can get in the inner workings of actual virtual machines. Trojans kind of go without saying. Keylogs are definitely much more prevalent, especially when you think about people trying to do things for financial gains or gaining execution or access to a machine. Then we have grayware, right? Adware, spyware, the bloatware that comes on brand new computers, if you will. Those are forever going to be around. But all that malware has to have some method to hide, right? Unless you're like Rick James and you don't really care, typically you're going to want to hide your malware. And some typical aspects to do that is you're going to use some type of packer, maybe it's UBX or something else, where you want to add your malware in with some legitimate program. Maybe you want to use an encryptor in which if somebody was trying to RE it or reverse engineer it, then that payload and aspects of that data may be encrypted. It may be much more difficult for them to actually understand. Polymorphic, much more sophisticated, consistently changing its data set in itself as it traverses, right? Think of how signatures are ever going to find that heuristics. Good luck, right? So polymorphic is definitely much more sophisticated. And then we have stagers. Stagers, definitely on the rise. And this allows us to really survey a machine or do something to a machine before the real malware comes, right? So we can all think about some sport, maybe it's boxing. There's the main ticket, and then there's these other people who are boxing before the main ticket. We can almost think of those other folks as the stagers, right? They're prepping the battlefield, if you will, getting everybody hyped for the real deal. And the real deal is going to be the malware in which the stagers come get. So a little bit more about these stagers. We know them as droppers, downloaders, but nonetheless, they should be tiny, right? You typically would not want to use a full meg or two payload as a stager. But generally speaking, if we're going to exploit on, if that is the method in which we're going to use to get on the system, we may have a limited amount of space that we can actually use for our payload. And this is where a stager actually comes in good with us. And once we get access to that machine, our stager should allow us to actually interact with that machine, i.e. our stager will have that machine contact us so we can then either task it for something else or send an actual real payload that's going to actually sit resident on the system. Now, the big thing about this is it allows us to break down our tool set. Malware development is really expensive, either money-wise or man-hour-wise. But nonetheless, I'm not going to free willy-nilly just throw my payload all over the place and see what sticks. I want to get on the system, survey it, understand if it's even a good candidate for me to do something with it, and then at that point, then lay it down, right? Maybe my surveying is what type of antivirus they have on there. What's the state of the system? Is this a system owned by somebody like my mother who doesn't know much of what's going on in the system? Or is this some aspiring young computer science or some type of admin person who's really into the machine? Now, looking at the delivery mechanism, we have something like this. We have the system being exploited and our stager being part of it. And then we have the system reaching back out to our C2 server. Generally speaking, when that system reaches back out, it's probably going to be on some type of well-known port in which general client machines would talk on, right? So I probably wouldn't have my stager hosted at, quad 4s or something like that. It in that case would blend in a lot more with normal traffic. But when it reaches back out, and we're talking that middle tier there, then I may have something else for it to grab. And it could be virus, worm, something else, right? It could be just other instructions. But nonetheless, it's like that main ticket for that heavyweight fight, right? That system's gonna then reach out and grab whatever that next stage is. Once we have that, we're gonna set up some type of encrypted C2 channel where periodically, every day or whatever the case, we would then have the ability to interact with each other. Generally, I wouldn't have that C2 server actually initiate communication with that implant or whatever my follow-on payload is. I'd have this guy on some period of time, random period of time. Like, I don't want the periodicity to be so clear-cut where you could be like, hey, every 3 hours on the dot, this thing is actually reaching out. But some periodicity in which this guy may come out, check my C2 server, see if I got anything else for it, and then execute it. Some other common tasks goes without saying. I want to survey it. What is the state of the machine? I may have some other payloads that I want to lay down, but I want to ensure that that system has the requisite software installed, or maybe this thing doesn't hold any true wealth for me to be able to do something follow on within the organization. But this also allows me to validate whether it's running in a virtual machine or not, right? Maybe this is some honeypot of sorts, or if I understand that organization and most of their stuff is virtualized, then I could really deem that is normal, if you will. The other thing about us using a stager is that additional payload we reach out to grab we could actually inject that into memory, reflectively inject that DLL. And at that point, our DLL wouldn't touch disk. So we're being a little bit more stealthier in that aspect. When we look at just a generalized methodology of sorts, we can refer to the cyber kill chain. Cyber kill chain has been around since roughly 2011, developed by Lockheed Martin. And there are a number of methodologies that all kind of articulate the same thing, but ultimately just highlight really how somebody would look to do something. So the interesting thing about this is going to be linear in nature. Every step is almost required for the next. So if I had my young child here, my little 5-year-old, and I was chasing him, it would be me trying to catch up to him. Instead, I'm going to try to pass him, get in front of him, so I can then block him or entertain him or whatever it is my goal is. So the goal here, or really the idea here from a defense perspective, if you can identify the methodology in which an attacker or an adversary would take, you can then get ahead of them. So that way you're not sitting there trying to follow, but you're more or less getting around and then blocking, stopping, identifying, mitigating aspects in which they would need to achieve to further go along. What we're really going to focus on here, though, is not the exploitation perspective. We're going to focus more on the installment piece, where we're actually going to lay something down, and then we're going to utilize that to communicate back with our C2 server. All right, a common tactic to do this, I wish I had a disclaimer here because this is not the only way. It is one of a few ways to actually get after it. It's almost like eating a Reese's, right? There's no wrong way to really do that, unless you dip it in milk. That's not right. So a way to do this is we'll take whatever our data is, we'll convert it to bytes, we'll base 64, and then we'll store it somewhere. So the premise of this talk is utilizing enterprise services. This is specifically Microsoft. We're going to utilize the very things that Microsoft calls features, and we're going to store some code there. This code today is going to be benign. It's just going to print a string back to the screen to let me know all is well. But this approach is very post-exploitation, right? This isn't telling you how to get on the box. You're already on there. Now you're looking at the next stage. And this kind of fits the category of fileless, if you will. So the interesting thing about this is what we're going to lay down as our stager is going to be an IP address, or it could be a URL. And then we're going to lay down a URI off after that, actually specifying the file that we want it to download. So what do we lose if that gets burned? Well, I lose an IP address if I'm using an IP. If I'm using a domain, I lost the domain. I can go buy another one for $1.99. And then whatever I specify as the file that I'm downloading, I could lose that name, right? That doesn't really help a defender because today, the file that I'm going to host is called stager.ps1. But if you ask somebody what's in that file, nobody would know unless they went out there and downloaded a sample of it. So what are you really losing, right? I'm lessening the surface in which I, as an offensive person, could become burnt or show my hand as to what I'm doing. All right, so we'll start with Active Directory. Active Directory from an enterprise perspective, that's going to be the authentication authorization mechanism for user accounts throughout a network. Same thing with computers. Active Directory is a structure in which is typically arrayed of objects, and the most common objects are the users, computers, and actual groups. Now, the database itself is stored in System32 ntds.dat. So if we were trying to take over an organization, maybe dump some hashes, it's not about us getting a SAM hive because that's going to be local. In an enterprise, we would want that. But that's another talk. The big thing about this is when we look at Active Directory users and computers, we see the top screenshot there. Cool. We see things like OUs, organizational units, and then we have sub-OUs there as well. And then under each one of those organization units, we may have other objects. In this case, we have some users, we have some groups, we also see some sub-organizational units as well. The interesting thing about this is people are typically quick to create users. They're not always typically quick to delete users. Or if I move from one section to the next, they may give me or change my rights. They may not go back and take those. So we see things like privilege creep and a number of other things come up. But from a GUI perspective, that's how an admin may look to actually access Active Directory. We can utilize something like PowerShell and access Active Directory as well, and we see the same names there that we see as part of that OU there. If we were to click on an actual object, we're presented with a number of properties about that object, and roughly there's about 50 of them. If we go tab to tab, we'll see these properties. And generally speaking, each one of those properties has the ability to store some amount of data, whether it's one character, 512, right? It just really varies from field to field. Now, there's also a number of fields that are not shown by default, generally speaking, in each one of those tabs. If you're familiar with Active Directory, you can go along the toolbar and actually enable advanced features, and you'll get things like Attribute Editor. Now, in Attribute Editor, we'll be able to see the fields that are not typically shown by default, and I'll highlight that as I do the demo. So when we looked at this user, we're looking at the same stuff within PowerShell. So this is good because if we can get our code in there, our stager, domain users by default have the ability to read objects in Active Directory. So that's cool. Now I can almost be using this as a file share, if you will, and I can go from box to box and have that user read that actual account and grab that code. So now we kind of move to the registry. The registry goes without saying, it is amazing. From a defense perspective, it's awesome for forensics and artifacts. From an offense perspective, it is like a kid in a candy store. There's just too much, right? So if you ever meet an admin that can tell you about every key in the registry, I'd be interested, right? Because there's just way too much in there for any one person to be able to know every particular key. So if that's the case, that makes a good place for us to get our code in. And the fact that we can get our code in allows us to really skate under the radar a little bit more. Now, when we look at the registry, we have the hives that sit on disk, and then we have the hives that are loaded into, or what they assemble into in memory upon the system booting up or somebody actually logging in. So in the user's profile, there's an ntuser.dat that is specific to the individual user. When he or she logs on, it becomes their HKCU. And then we have, in System 32, we have stuff like HKLM, software system. Those, along with a number of other ones, become what we know as HKLM. Now, we also see the linkage between those items. So we have our hives on disk on the left, and then we have what they become in memory on the right. The good thing about this, or not really the good thing, is if we were trying to affect the security hive, when the system boots up, it gets loaded into memory and it's locked, right? So that's really, really good in the sense that we know it's going to get used. It's going to be loaded in. So if we can get code in there, it's a high availability method for us to actually use. If we were just looking at the registry, we're used to seeing reg editor, right? And for us to store code there, I like to go several layers deep. I like to look for just random places. I don't even care what the key is really used for, right? Because the more deeper it is, the less likely somebody's going to be looking at it. So in this case, we're not very deep, but we're in the user's hive. We're within software and then sysinternals, and then I see a key for the EULA. So they've used strings before, and they have accepted that EULA. And then I can look at the same data by utilizing PowerShell, and I see the EULA highlighted there. The short here is we're showing that you can utilize the GUI, but you can also utilize the command line. Now, this is going to be key once we get into the demo piece, because largely everything I'm going to do is in command line, and then we'll go back to what it looks like in the GUI, because that's what most admins are going to be utilizing. We also have event logs. So this is going to be detailed records of things happening on the system. Generally speaking, we have audit entries that, if enabled, will write to event logs. If somebody was going to wipe an event log, it would generate an event 1102. So that gives some reassurance to an admin that if they can write stuff to the event log, they have a good record. The interesting thing about this is there's a huge amount of event logs, like huge, right? We see where those event logs are stored at on disk. There are some tactics to wipe event logs in a good way. Actually, I can't think of any good reason why anybody would want to do it. But if we were doing it from an adversary perspective, there's a couple of tactics that we can do it without an admin being able to see it. They do overwrite themselves. So an admin likely would have something write to the event log and then ship it off to like Elk, Splunk, or whatever their centralized log aggregation server is. But when we talk about there's a huge amount, just looking after a Server 2016 virtual machine I had default, nothing special, I had roughly 380 unique logs. Not talking about log entries, we're talking about unique logs. Now, generally, admins know about security, system, application, maybe some small other ones, but I don't know how many people can name more than 15, 20 logs that are actually in the system. So the fact that we have several hundred gives me some pleasure in utilizing this. Now, reading an event log, we would use Event Viewer, the GUI aspect, and we would see an actual message and we see some other data about it. We can utilize PowerShell, as you see below, to essentially read that log as well. Now, if that's not enough for you, you have the ability to write custom logs. So from a defense perspective, maybe I have my dev shop who developed this in-house tool and they didn't build in any inherent logging. So now I can utilize something like PowerShell, write my own custom logging to get it in the event logs. From an offense perspective, I see a place in which we create our own event log. Heck, if we already got 385, what does it matter if we have 386, right? We'll just add one more onto it, and now we can write our code there and go back and retrieve it at another time. Reading it is such like this. So I've made a new event log, or actually I made a source within the application event log, and then I wrote just an app has started. And then when I go look at that in the event viewer, I see the actual message that I depicted. And then I also am able to read that very same thing utilizing some PowerShell. We have group policy. So group policy is going to be that infrastructure that's utilized to implement specific configurations across an enterprise, right? I remember my time as a help desk person, right? They told me I had the most important job in the organization. That was right before they gave me the most work in the organization, right? It was like, hey, we need to update these machines, and we didn't have centralized management, so I was walking around with my disk. Now I'm dating myself. I had a CD book with all kinds of software, and I realized that was no way to treat a human being, right? And we have things like group policy where we can set it once and then have those settings proliferate across an organization. So it's a wonderful thing. And then again, we find areas that we can take advantage of it from within Microsoft. Group policy itself, there's an enterprise management perspective, group policy management, and then we have the local machine has a local group policy editor as well. So we're going to look at doing it from a enterprise perspective. That's going to give us the most bang for buck, but either one of them will suffice. And the way we're going to do that is we'll look at the group policy management from a server perspective. I have a default domain policy, which every domain would have that. I don't care if it's enforced, linked or not. But we have this thing called comments. And over there, I've never seen an admin actually use that, ever. So for this, for the sake of this screenshot here, I just put in that this is the default policy linked to the domain or whatever the case, right? I'm gonna put text there now, but we're gonna utilize that area to store our code. Awesome. Now, before I lay any code down, I'm gonna understand the infrastructure to really highlight, would this tactic work? Like, I'm not going to go to every machine and try to use MS08067, right? Because that's not going to work everywhere. But I would want to understand the target in which I'm interacting with. Now, our next one is alternate data stream. And some of you may be like, man, really? Yeah. Hey, it still works, right? Just like that 6.7 one I just talked about. So alternate data streams resident within NTFS file system. Generally speaking, that's what our systems are going to be from a Windows perspective. We have the ability to really add in this stream of data, if you will. And if we looked at the size of the file, our data stream size does not affect our actual size of our file. So that's good. Now, this was really developed to have interoperability, capability match with Macintosh systems, but it's still something that's available. So every file has a $ data stream. And then we have specific files depending on how your system is arrayed, but we could also have zone identifiers. Have you ever been downloading a file, tried to run it, and a pop-up said, hey, be careful, this came from the internet, you shouldn't trust stuff, blah, blah, blah. Well, that was a zone identifier ADS that was attached to your file, saying that zone 3 or 4, or whichever one it is that tags it saying it came from the internet, that's what's highlighting or really stopping you and prompting you. It's that zone identifier ADS that's being tagged. So an example of this is really this. So I have a file that I've created, and right now it has 0 bytes. I created an alternate data stream that I'm going to call my stream, and I'm going to put my son's favorite, right, Dr. Seuss in there. And right now, the length of that is $35.99, but still, the original file, the donor, if you will, is still at 0 bytes. So if I'm going to use this, I would look to want to do it on a file that I know that's going to be there, right? And one, for example, not the only one, is the host file, right? The host file, if I'm going to try to sinkhole a domain or maybe redirect something locally, then I could utilize this host file and put in an IP in an actual domain. But regardless of what's in the actual file itself, I'm just going to be a strap hanger with my alternate data stream. And really, this thing's going to be a donor for me. All right, we have environment variables. They're going to be dynamic in nature. So if we were using the environment variable user profile, it would really highlight the profile path for the user that you're logged in as. For example, if I'm logged in as a user called Wolf, and I said, hey, change directory to environment variable user profile, it was dynamically set to that environment variable that my user profile is the path of C users, Wolf, blah, 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 right? So it can be dynamically set, and this is good. Now, we also have the ability to have user environment variables and system ones. We're going to look to get into system ones so that way it doesn't matter per se which person. There's a lot of information that's being utilized here to really set what's going on in our operating system. And the same could be said about whatever programs we have installed there. The same way we have our environment path, we can add other things in there. So in this case, we have our user environment variables up top. I have the system ones that are down in the bottom. These user ones are in my ntuser.dat for whatever user it is that I'm logged in as. And then these system ones are part of HKLM. From a GUI perspective, or more from a GUI perspective, I have where I can go into properties of computer, and then I can see up top my user environment variables and down below my system ones. So we're going to add one into our system one. We'll come back and check this screen, and we'll look at what an admin would actually see and how he or she could actually highlight that we have something going on. Then we have WMI and SIM, right? So from this perspective, WMI was Microsoft's implementation of WBeam. So WBeam's like how we're going to share information across a subset of machines. Within the last couple of years, Microsoft has gone away from that and went to SIM, which is Common Information Module or Model. Both of them somewhat do the same thing. WMI is going to use DCOM. SIM is going to use a thing called WSMan, but ultimately the namespaces and classes that we're accustomed to from WMI are still available. So we're going to take advantage of that in the sense of we have these classes, namespaces that have a particular set of information about them. So these classes has properties and methods, and properties are nothing more than attributes. Methods are nothing more than actions. And then if we want to interact with them from a GUI perspective on our system, WBeam has an actual executable in System 32 that we can connect to our machine and access all our namespaces and classes. And we'll highlight that too in our demo as far as how an admin can see that. But when we talk about the sheer amount of them, it's going to vary from system to system. Just like when I add a particular piece of software on my system, it may add a new registry key. The same is said for WMI and SIM as far as classes. So on the machine that I ran a demo on, I had roughly 10,000, right? Refer back to my comment about the registry. If I can find an admin that can tell me about more than 10 classes, I wouldn't be shocked. I would want to actually talk to them a little bit more, right? But 10,000, that's a lot just on my system. So if I have 10,112, what difference is it going to make if I add one more to it, right? And that's what we'll look to do. This is going to help us with storing our code, having it in a place in which an admin largely is not going to see it. So that makes it great for us when we want to come back and actually grab it. Okay, so now we're going to demo, and I didn't think this part through because I didn't mirror it. So okay. All right, cool. So I have another machine that is running a web server. And this web server is really dirty. It's really dirty and nasty. So you heard of Python simple HTTP server, right? So we did the same thing in PowerShell. We're talking 19 lines. We'll probably get it down more than that, right? So it's really quick and dirty. It's HTTP. I can add a certificate onto it if I needed to. But nonetheless, I can utilize something like invoke web request, and I can access that server. So I'm just ensuring that I have access to it. I see I have a status code of 200. Cool. So I'm going to take what is really my stager, and it's that bit of code. Where I'm going to reach out, download whatever is being held there, and I'm going to store it in the context of memory. So that whole string itself is going to be my stager. If this gets caught, I lose an IP address. I lose that I was reaching for something called stager.ps1. But honestly, I could have called it 123 or ABC, Mickey Mouse, or whatever, right? Or not United States, or whatever, right? Cool. So I'm going to go through and I'm going to take that string, I'm going to convert it to bytes, and then I'm going to convert it to base 64. And then I have that base 64 code. So now there's my obfuscated string in which I'm going to lay down in a number of places. As you see, I have it as encoded text. So as I go through these examples, I'll be storing encoded text, the variable, in all these random different places, and then we'll call upon it. So I'm going to utilize this person, Nick Shank, and I'm going to look at a couple of properties associated with their account. And right now we see employee ID, employee number, division. Those are the three I called upon, and they have nothing there. Division can hold 256 characters. I want to say employee numbers like 512, employee IDs like 16. And there are many more that you can find, but those three aren't available by default. So what I'm going to do is go into Active Directory, and I'll go into Shank's account, and I'll come into Attribute Editor. When I come into Attribute Editor, I notice that division has nothing there. So that is the one place that an admin would see it in Attribute Editor. Now I would have had to essentially do an advanced view, and I don't know admins that just scroll down Attribute Editor like, oh, let me see what's going on in here. So if that is the case where an admin's going to do that, then I'm going to get a little bit more stealthier. But first, I'm going to store this base 64 code there. We'll look at what it looks like. Cool. So it's there from a command line perspective. From a GUI perspective, we now see our base 64 code. And depending on the target, I might be like, cool, it's there, let's go. Or we may want to get a little bit more stealthier with that, so we're going to push that down a little bit. And what I mean by push that down is I'm going to pad it with spaces, right? I'm going to push it off the screen so that way it forces an admin to actually interact with it to know it's there. Now, I said division takes 256 characters, right? Employee number takes 512. So if I'm already going to pad it with 250 blank spaces, then I'm going to now put it in employee number. Now, when I go back in here and I look at employee number, we'll see what that looks like. So employee number shows blank, but notice everything else around it that's not set, right? It actually says not set. If an admin gets to this point and was like, huh, why is that one not set, and why is it doesn't have anything else next to it? And they want to double click it. You got me, right? So let's go a step further with this. We're gonna actually add in not set. So we're gonna add in not set. We're then gonna push it down 250 white spaces, and then we'll add in our text. So I'm gonna now overwrite employee number with that. So we'll go back in here and we'll look at that. So now when I look at employee number, nothing to see here, right? Now look, if an admin is gonna go double click every one of these, look bro, you got me, right? Like you have no real job, right? But now when I go in here to actually interact with it, I see my code, I see my white space, and I see not set. I pushed it off the screen, making it more difficult for me to find. Now, when it's time for me to actually execute this, what I'm gonna do is call upon that property, I'm gonna trim not set, and I'm gonna get rid of the white space there, and I'm gonna actually feed that base64 to PowerShell. And what I have is stager.ps1 is nothing more than that green text saying stager test, right? Call it a proof.txt on the desktop, if you will, your OSDPN or something. All right, cool. So that's a way for me to do it. Now, if I get a new guy on my team, right, everybody's got to cut their teeth somehow. So it's like, hey man, welcome to the team. Hey, check this out. We're working on Active Directory. I need you to go through every property known to mankind and research and find us a property that we can throw data into, right? Good luck, right? We all have to like start somewhere. So that's a way for us to do it. Now, from a registry perspective, I'm gonna utilize this key called console. And console itself is like super random. I just scrolled down and found it somewhere. Like that's how random it is. Now I can't find it. All right, cool. So there it is. So we see nothing's under console other than something that says default. That's awesome. So I'm going to create a new item there, and I'm gonna call that value updater32, and then I'm gonna store my code there. Well, why are you calling it updater32? Because let's be real here. If you add 32 or 64, people will make themselves feel like it's legit. Like, hey, yeah, it looks legit. It's got 32 on it, right? So we come back in here, we look at this, and you're like, ugh, that's ugly. Now we'll go back and forth because I'm like, bro, this thing is like 6 layers deep. Ain't no admin gonna find that. And you're like, yes, they will. Okay, fine. We'll do something similar to like what we did before. We're gonna push that thing down. In this case, I'm gonna do updater 64. I'm gonna pad it with 250 white spaces, and we'll write there as well. So when we come look at this, we now have that. So if an admin's at a point where they're looking at registry keys and they see a key with no value and they want to click on it, really, I guess their indication are these 3 dots here. But if they get to a point where they see this and they want to click on it, then cool. I guess they'll stop there. But if they're really nosy, they could scroll over and see my code. Now, if I want to make this blend in a little bit more, you see how we have this key default and it says value not set? That seems really legit. So I'm going to do that, right? So in this case, I'm going to do app cache 32. I'm gonna add in value not set, add in my 250 white spaces, and I'll add in my code. So now when we have this, we have value not set. We have some 3 dots out to the side, so if that triggers them, so be it. But when they click on it, we have value not set, all the white space, and then we have our code. So if I get this in such a place where I'm rest assured no admin is looking for it, depending on the defenses, I feel like I can get around it. When it's time for me to call upon it, I'll trim that white space and everything else associated with it, and I'll be able to execute it. Now, from a event log perspective, I'm going to create an event log, a brand new one. It's not going to be system security or anything like that. I'm going to create one called Windows Updater. So that is really legit. And I'm going to utilize a source called updater64. So now that I created this event log, I'm going to write data to it. And the data I'm going to write to it is going to be an event ID of 10. And you guessed it, it's going to be my base64 code. So when I come in here and I look at this, we'll be able to actually see it. Okay. You ever had a talk with the demo guys and it was like, yo, bro, I got you. You're going to be good. All right, there's my updater 64 or my Windows updater. When I look at that, I got base 64 sitting right there, right? So I'm like, cool, there's 386 logs now. What if they see this? And I'm also doing this in my own log because if I did it in the application and everything else, we've already said it's gonna roll, it's gonna overwrite. So I don't wanna lay down something today, try to come back and utilize it tomorrow, and then like the network had so much activity that my log or my entry is now rolled. So we'll add some white space in there, right? Because white space saves everything. When we come back in here now and look at our next entry, we see nothing there. We scroll down, we'll see our code. So now what I want to do is I want to essentially, when I look at like an application log or something, there's some text there and I read it and I'm good. I typically don't interact with it or try to scroll down. If I see text, white space, I assess that that's the end of it. So what we're gonna do is try to get past the human nature in that same respect. And I'm gonna say an update was detected. We'll add in 50 white spaces in our code, right? Surely if this is the Windows Updater event log, surely something like an update was detected is legit. So now we come here, we see an update was detected. If they scroll down, they'll see my code, but at that point, I feel pretty good. I'll sleep good that night. I may worry the next day if I'm waiting on the beacon and we're like 3 minutes past that time. I might go smoke a cigarette and I don't even smoke. All right, so cool from an event log perspective. And the same thing, when it's time for me to actually run it, I'm going to call upon that entry. I'll trim all the white space and everything else that I have on there, and I will let it rip. Now, from a event log perspective, we have the comment field. There's not a way from the GUI that we can edit the comment field. It would force somebody, if they're going to use it, to utilize the command line. So for us to get after this, we're going to read in or call upon the default domain policy. I'm going to change the description with, you guessed it, my text. And now when I come look at this, I'm like, whoa, that can't be good, right? Because even if an admin is just quickly browsing through, getting ready to interact with it, something like that may stand out. So you can kind of see what we're gonna do here. We're gonna suppress everything. Now, before I was able to use backtick in for new line, but for some reason backtick in did not work here. So I found myself almost like I was trying to overflow a buffer where I was writing in like no characters, like, oh, okay, I can still see it. Oh, let me do another one. Okay, now I can't see it. That's the magic number. Cool. So I added in roughly 40 or so blank spaces, and then we'll be able to actually write it there. So we'll execute that. Cool. Now we'll come back in here and we'll look at it. And we see it's now off the screen. Awesome. If we want to actually call upon it or just read it, we'll see something like that where we have all this blank space in our code. If an admin's reading group policy objects utilizing command line like this, our mileage will vary. But when it's time for us to execute, you guessed it, we can trim everything and be good to go. From a host file perspective, I'm going to just call in or read in that string. And then I'm going to add content to that file, a value of my base64 code, and I'm going to add it to a stream called zones, right? Why zones? Because it felt good in my soul. When you look at this, right, just looking at what ADSs are there, we'll see something like this. And if somebody's looking, that data, $ data is going to be the default one. And I just added in zones because it felt good, it looked good, smelled good, all that good stuff. So now I'm going to read in that data, and then I'm going to pass that to PowerShell so I can actually have it execute. All right, I'm digging it. All right, so we got two more. The second to last one here is going to be dealing with environment variables. So when I utilize PowerShell to affect environment variables, I'm going to create one, but it doesn't persist past my current session. And I'm also going to create a system one, but it needs to restart this. The system needs to restart before it kicks in. So this first one is creating a temporary one, and then that second one creates my permanent one, but it again won't kick in until the system restarts. What I'm going to do is come back over here and really look at where that's at. So I have a number of things that are there, and we see the one that we created. There was already a W6432, so I created a W64 because it felt good, but again, it stands out if somebody's looking at this. So we're gonna pad it with some white space. Awesome. Come back in here and look at it. And now we have this ugly blank one. So instead of us doing value not set here, I'm gonna use a donor, if you will. I'm just gonna copy what 6432 has as its entry, also save it here, and steadily have my white space and push down my actual code. So I'll read in what 6432 has, and then I'll execute nearly the same thing, starting that entry off with the code that 6432 has. And when we look at that, we see our W66 with the same thing as 6432. And if we were to open it up and interact with it, we have our code, we have some white space, and then we have C program files, common files. Ultimately, I want an admin, if they're gonna investigate this, I want them to feel like there's nothing to see here, just keep moving, right? I also want to be a snitch and be like, hey man, don't look at this event code. Go look at, this registry key, go look at that one over there. That's who you're really looking for. When it's time for me to run it, trim my white space and be good to go. From a WMI sim perspective, again, roughly 10,000 on my machine. I'm going to create one called Win32 Defend 64 because largely a decent amount of the classes begin with Win32. So I want this to blend in. I'm going to create a property called path, and I'm going to store my code there. And then when I go back to read it, I'll be able to see my code. Now, this class is now one of 10,000 plus entries on this system. When it's time for me to execute it, I just call upon it. Now, I don't feel like I need to further obfuscate that. If somebody wanted to actually look at these classes a little bit deeper and they knew which one they were looking at, they could actually use this program, inherent to Windows. And from here, they could specify recursively all roughly 10,000 or so, or they can do the immediate ones in that namespace. And from that perspective, they can then scroll down to something that they're looking for, maybe get to a point where they see Win Defend 64. Notice we don't see our code there. And if they had a wild hair, they could then interact with it, come down, and they would see the property in which we created. Lots of work. That's good. All right, so as you see, there's a number of ways for us to do this. Now, you may be wondering, well, people really using this? Hey, look, from an objective perspective, don't trust what I'm saying. Let's look at what the data says. So we have a number of organizations, nation state, hacktivists, whatever you want to call them, that are utilizing stagers in some form or fashion, right? And this is just a small list. When you think about it, it only makes sense. Like, why go all in when you can kind of taste the water a little bit to make sure it's what you want before you put your hard-earned equity on that actual system? Now, we do have some pros and we have some cons. So the pros, very lightweight, could be low equity, absolutely. Because again, if I lose that, what do I lose? A domain, maybe an IP address, maybe, just a name of what I call the file, and that doesn't even mean anything. It's modular. So I have this stager that literally goes and has one job. And then depending on what it brings back to me for information, I could have a module that then surveys. I have a module that's a keylogger. I have a module that's this, right? So it's very modular in nature where I don't have to bring everything at one time. And literally my C2 server could be hosted anywhere. The same with my stager. It's like if there is a place for me to store it in Windows, and there is a million places, they're called features. It's a place in which I can go back and grab it. Now, with that, there's some work that has to be done to even get to this stage. We're talking post-exploitation. So if you can't even get in the door, you won't even get to the point of using this. And some defenders are better than others. We can all agree with that. So as we begin to use this, really it's visible then the next stage of our retrieval. It's going to create a connection. So if there's real decent logging and somebody's actually looking, it could highlight that. If the organization has a good EDR, we could be seen as well, right? This is where you understand the environment and then you pick which tool is applicable for the task at hand. We could find ourselves rather in a place in which our C2 server is blocked if we're using a domain or really even an IP. If we're using a domain, if the organization finds it, they could sinkhole the domain and really neuter our communication. So there's a lot riding on us using a stager in that perspective. Some detection mitigation strategies. Well, proactive threat hunting, like come to work and actively go look at stuff on your network. Assume breach. Well, it's quiet. That's because they're good. I'm telling you, if you go look, you'll find stuff. Right? Reputation-based web analysis. What does the rest of the community think about this domain or this file or whatever the case? What does my organization think about it in the sense of, is this file resident somewhere else in my system? Mitigations, least privilege, segmentation isolation, application whitelisted. It hurts, but man, if you do it, it's worthwhile, right? Somebody still can do some nefarious stuff, but at the end of the day, we're making it harder for them. It goes without saying, patch. All right, so cool. Now I'm on the down street, right? Making my descent down the end. And I got to get these shameless plugs out, right? It is what it is. I apologize, right? So you see me use a lot of PowerShell up here. You guessed it, I like PowerShell. So I run a site called underthewire.tech, myself and 2 other people, and been around for roughly since 2015. We've had over 90,000 people play from 78 countries. When I Google how many countries there are, I get somewhere between 192 and 196. Either way, I'm pretty happy with those stats. It's free and it's persistent. It's going after the core aspects of the language. So if you're looking to utilize the language a little bit more because you maybe thought what I was using it for was pretty cool, then here's a way to kind of get after it. Now, if you feel like you know the language, I also run a site called Posh Hunter. So Posh Hunter is very offense and defensive minded. I'm going to put you in a scenario in which you're either a defender or you're a vulnerability penetration tester, and you're going to answer questions utilizing an operating system or a Windows instance that we're providing you. All right, so if you have questions, I'll step off to the side and answer them. If there's anything that you want to take a picture of, this is it. When I get back home to Augusta tonight, I'm going to put these slides up there. If you want to interact with me on Twitter or anything, there's that, and there's my code. So again, I'm going to step off to the side, so if there's any questions, I'll take them then. Thank you.